Hi everyone. I just wanted to thank you for being with us today. Today's PowerPoint is to go over basically like getting your garage EV ready. And basically the goal of this PowerPoint and presentation is kind of putting together my previous presentations on how to buy an electric vehicle, kind of like what to look for in terms of like how large of a battery you need and things like that. So this PowerPoint is tying in, like what you need at your house in terms of, electrical and how large of a service panel you need and those kinds of things. So just a disclaimer to begin with, I'm not an electrician or an electrical professional, but I have enough like research and stuff like that and have seen enough different kinds of installations that hopefully I can at least like give you a pretty good, base skill set to kind of go to an electrician with and kind of give you enough information that you know what you need at a minimum, but also not get recommended something from an electrician that's overkill for your needs. So um, there's different things that might apply to your locality, and also there might be changes to the National Electric Code from the last time that I've seen things. So I just want to make sure that that is touched on. That you should, unless you're like really comfortable with electrical, you should contact an electrician to undertake undertake the work. So there's a lot of new terminology with electric vehicles and charging. So I just want to go over that really quick. So a watt is a unit of electrical energy, and with in terms of an electric vehicle, it's basically like propulsion of the vehicle and moving it. So how much work can be done by electricity? A kilowatt hour is equal to 1,000 watts. So one of our conversions that we'll be using is 1,000 watts to a kilowatt. A kilowatt hour is a unit of energy in 1 hour's time frame. And it's usually an expression of like energy storage or energy consumption. It's like your electrical bill is commonly billed by kilowatt hours. Um, and a calculation for watts is watts equals amps times volts. So if you kind of go back to your, high school algebra or even college algebra, just watts divided by amps will be equal your volts, and then watts divided by volts, that will be your amps. So we'll be using those some of those calculations going forward. Electrical calculations for your home garage. So if you take nothing else from this, and your house is capable and you can handle the costs and everything just fine, a 50 amp circuit is pretty ideal for like future proofing. It provides more than enough range for almost everybody. So you can just run one 50 amp circuit out to your garage, and that will like pretty much cover two cars pretty easily. 50 amps covers up to 288 miles per day, roughly. Some of that might rely on future proofing. So, like early electric vehicles might not be able to handle that much electricity at once. So usually they're limited to like 6.6 kilowatt hours. But later vehicles can take upwards of 80 amps. So it kind of ranges, but 50 amps is in terms of like the number of miles that can charge every night. It should be more than adequate for most two-car households. So, for instance, you could swap vehicles every other day, and that would cover your needs in general. Um, Volts times amps divided by 1,000 equals kilowatts in a circuit. So, our 50 amp outlet, it can provide 40 amps because uh, any circuit is only allowed to have 80% continuous load on it. So 50 times 80% equals 40. So 240 volts is kind of like your standard dual phase um, circuit. So 240 times our 40 amp, that's going to be on the breaker, divided by 1,000 equals 9.6 kilowatt hours. And typical cars, in terms of efficiency in the winter, the heat is kind of like your limiting factor there. Heating takes a lot of electricity, so you typically get 3 miles per kilowatt hour. So that's the unit that we're going to be using in our calculations going forward, because that's kind of our worst case scenario. So you might get even better numbers out of this if you're in the summer or if you have extended driving. So how do I figure out how much power I need to run out to my garage? So in our example, a vehicle with a 60 kilowatt hour pack, that vehicle can accept about 7 kilowatts of power. So in this instance, we're trying to figure out, like how much power we need to run out to the garage to get the most out of that charge rate. So we're going to convert 7 kilowatts into watts. So we have the units that we want to figure out how much amps that we need. So 7 kilowatts times 1,000 equals 7,000 watts. 7,000 watts divided by 240 volts will give us 29.17 amps. However, as you probably know, with any kind of electrical in your house, nothing's in fractions like that. So we're just going to round up to 30 to make sure that we have enough for our needs. So we'll need a 30 amp charge rate if we want to get the fastest charge times possible. And as I mentioned earlier, we can only run 80% of a circuit breaker's rating for a continuous for a continuous load. So a 40 amp circuit is probably what we'd want out of that. And then we could run a 32 amp charger off of that. An important note is the kind of like whatever is the lowest factor is kind of like going to be your kind of your bottleneck. So you want to make sure that whatever your limiting factor is going to be like how fast you can charge at. So if your car can't take the 32 amps, then it would be kind of stepped down to whatever your car is capable of. So calculating power needs for your commute. So in this instance, I have like a daycare drop off and then I come into work. So my round trip commute is about 50 miles. So I'll use that for my example to figure out exactly like how much power I need to basically, make my commute every day without any errands. So 50 miles divided by 3 miles per kilowatt hour. As you may recall, the 3 miles per kilowatt hour is our worst case winter efficiency. So that will give us 16.7 kilowatt hours that we'll need for our charger per day. So you can adjust your miles to your needs to calculate your minimum power needed. So if you have, a 20-mile commute, you can just put 20 into here. And then 16.7 kilowatt hours, that's what we got for our minimum power needs. So we're going to multiply that by 1,000 watts, and that will give us our kilowatt hours. So we need 16,700 watts to charge each evening. So we'll take 16,700 divided by 8 hours. I'm just going to assume that you'll charge overnight while you're sleeping. So that's kind of like what we're plugging into here. You could plug in whatever you want in here. So if you want to, say if you're doing something in the evening and you just want to stop home and, get all of your commute back, you might want to just change that to like an hour or two. And then that will kind of give you just more variables to play with. So, but in general, I think most people and the sizes of batteries on vehicles now can allow for you to just charge overnight. So we'll just assume 8 hours here. So 16,700 watts divided by 8 hours equals 2,088 watts per power. But that's basically per hour. So we want 2,000, basically 2 kilowatts of power each hour in order to hit our goal of 16,700 watts put back into the battery pack. So 2,088 watts divided by 240 volts, that equals 8.7 amps needed. In general, that's higher than what we would need that's higher than a 120 volt outlet could provide us. So we're going to basically like go with whatever the lowest 240 volts breaker and charger would be. So in general, the lowest charger that is available on the market is around 16 amps. So again, going back to our 80% rule, we're going to have a minimum breaker requirement of a 20 amp breaker to get our 16 amp charger. So you'll charge much faster than this 2088 watts per hour. So that would be more than enough to meet your daily commute. Some of the common garage outlets. So we'll go over our standard wall outlet, and kind of the reason to go over these is like some of these might already be in your garage. So the NEMA 1450 and the 650, those are common plugs for, like RVs, like recreational vehicles, as well as welders. So if, the previous homeowner might have been like a handyman or something like that, or handy woman, you might already have some of these electrical plugs in your garage. So now you will know like how much range those can provide to your electric vehicle. So NEMA 515, the 1450, 650, and oh, sorry about that. NEMA 1030 and 1430. These two are your common dryer outlets. So a nice thing with those is you might like just for your like first winter or something like that, owning an electric vehicle, a lot of homes tend to have electric dryers as well as mudrooms. So some of like the newer homes and whatnot that some of us might have, you might be able to get by with outlet splitter and then being able to run a charger out through your mudroom, like coming into your house. So depending on where your dryer and that kind of thing is, you might be able to get by with that for a little while until you can, basically like upgrade to something dedicated in your garage. So it's a little less clumsy. So why are we going to use an outlet over hardwiring? And the reason I like outlets over hardwiring is serviceability, troubleshooting, traveling, and moving. So serviceability and troubleshooting. If your charger ever fails and you have it, like as an outlet, it's, like it's essentially like replacing like a wall mount television or any kind of appliance, because you don't need to call out an electrician to unplug your TV and remove it off the wall and that kind of thing. And then similarly with like troubleshooting, if your car's not charging and it's the charger, you could have somebody like come over to your house and basically plug in their charger and see if that's going to work with your electric vehicle. So if your car's not charging and someone else's charger will charge your vehicle off your outlet, you can like kind of figure out that it's not your electrical in your house, and it's also not the car. So in that instance, you'd probably just replace your charger, send it off for a warranty repair or something like that. And the big thing is you don't have to have $100 plus electrical an electrician come out to your house and do all that troubleshooting for you and the costs that come along with that. The other nice thing is with traveling and moving. With traveling and moving, you just unplug your outlet and you basically like take your charger with you to the next house, because at least now EVs are still pretty niche, so it's not really a guarantee that the next homeowner is going to take advantage of that infrastructure right away. So, and they also might want their own charger or have their own charger, so it just makes sense to take it with you. And then hardwire, like one of the really good benefits of it is some of the like Tesla vehicles, like they have extremely high power capabilities, so they can accept upwards of 80 amps. So as you might know with like home electrical, like some houses have a 100 amp panel, and that would essentially take up the entire load of a house. So, but if you have like a 200 amp panel, I think that's probably the minimum that you'd want for a 80 amp charger. So, but the nice thing with that is it gets you about 60 miles per hour. But more commonly, we'll probably see like 40 amps from a hardwired unit. But again, with that kind of comes, just some of the things that you probably want to be pretty comfortable working with electrical, or have enough spare funds that if there is any problems, you can call an electrician each time that happens. but it's not super common. But um, I would say maybe like once in 5 years or so, you might have an issue with your charger, and it might need a replacement or something else. So just early on, as the electronics improve and that kind of thing. Um, Also, your garage typically isn't climate controlled, so garages get a little bit warmer, so that might play a factor into like serviceability and longevity of these units. So our first outlet that we'll cover is a NEMA 515, and that's like your regular wall outlet that you'd plug your cell phone into or that kind of thing. So one of the things that is commonly needed for garage, like older garages, is some of them aren't grounded very well, so that might cause a electrical fault in the charger and allow your car not to charge. So you might want to have there's a little diagnostic tool that you can buy from like Home Depot and whatnot, and it'll just plug in there and say that it has all of the things that it needs. It basically has lights for like to say that there's neutral as well as ground and that kind of thing, and that's properly installed. So it's probably like a $10 or less little tool from Home Depot. Alternatively, you can just call an electrician and they could plug one of those in as well, or see what's going on. And the big takeaway from a NEMA 515 is that you can charge about 43.2 miles overnight, assuming that you're charging for 10 hours. So the reason I'm using 10 hours in these calculations is kind of you're in general, like you're probably going to have about 8 hours of sleeping time or whatever, and then probably an hour on each end that you're maybe winding down for bed and then getting ready for work in the morning. So I'm just assuming that you'll probably have 10 hours each day. So, but going through our calculations, we have 15 amp, 120 volts outlet. 15 amps times our 80% rule for a continuous load rate gives us 12 amps that we can charge with. So we take 12 amps times 120 volts, and that gives us 1,440 watts that we can work with. Divided by 1,000, that gives us 1.44 kilowatts. 1.44 kilowatts per hour times 10 equals 14.4 kilowatts overnight. And 14.4 kilowatts times 3 miles per kilowatt hour equals 43.2 miles overnight. Another thing that you could sub in for 3 is during the summer you could multiply that by 4. So during the summer you might, just have more things going on, like just, Minnesota, we have, we try to pack everything into our summers since winter is pretty cold and whatnot. So you might just be driving around more and things like that. So you could do 14.4 times 4 if you wanted to use that for the calculation, and then that will kind of give you how much range you could comfortably travel each day. So if your commute is less than 43.2 miles, you probably don't need any kind of upgrades to your household electrical. I guess the last note on your garage wiring is typically there's only one circuit that everything in the garage is running off of, so you kind of have to factor in if you have a garage door opener as well as like a garage fridge or freezer. I think that's something relatively common, is having like a chest freezer or some kind of like refrigerator in your garage. So you kind of have to factor that into the electrical load. So, but if you don't have those things going on in your home, then in general, you should have at least a 15 amp outlet run out to your garage in general. So 43.2 miles can generally be expected with no garage upgrades. Our first plug that we'll talk about is NEMA 1450 RV plug. So it's a 50 amp outlet, and 50 amps times our 80% rule gives us 40 amps that we can work with. And 40 amps times our 240 volts equals 9,600 watts. So as you saw from the previous example, all we can get out of our 120 volt outlet is 1.44 kilowatt hours. And here, that's, almost 10 times faster charging. So that's pretty considerable for the amount like that you could drive over and above our typical wall outlet. So 9.6 kilowatt hours divided by, sorry, times 10 hours overnight charging equals 96 kilowatts. And multiply that by 3, we get 288 miles per night that this outlet's capable of. So, um, that's going to be limited by whatever the lowest common denominator is. So if your vehicle only can drive 150 miles, like that's going to be your cap. Similarly, even though that we could charge 9.6 kilowatts off of this, if your car is only able to take 6.6 kilowatts, like that would have to be stepped down. So um, it's okay to have a 40 amp charger, but just know that your electric vehicle is not going to be able to take the 9.6 kilowatts. But you're essentially future proofing. So your next vehicle that maybe takes 9.6 kilowatt hours or even higher, you would get the 9.6 kilowatt charge rate. And then this is like the most common outlet found across rural America because it's at RV parks and campgrounds. So it's nice to have this capability because the other nice thing with having like the outlet chargers is that you could, take your NEMA 1450 charger out of your garage and then throw it in your trunk and, go travel to your cabin or something like that and charge at an RV park if need be or anything like that. The next outlet is NEMA 650. So it's going to provide the same capabilities as our NEMA 1450. However, one of the nice things with this outlet type is this has 2 hot wires and a ground wire. So this has 3 wires that are bundled in. So if you have like a really long distance for an electrician to install an outlet, this might be a cheaper option because you're not paying for an additional wire to be ran, say 100 feet from your your household service into your garage. And this is capable again of 288 miles per night, but again, that's going to be limited by your vehicle. So if you have a vehicle that's in excess of 288 miles, say like a Tesla that has 300 miles, then you'll be able to basically drive 288 miles per day and get a full charge every morning. Our next stuff that we'll go over is dryer outlets. So some of these are really nice again for like if you have a mudroom that's directly adjacent to your garage, you can just have the door open a little bit and run your your charger basically like through your doorway and into your mudroom where your dryer is. So that might be like a kind of a band-aid solution for say a month or two as you kind of get used to having an electric vehicle, and then when you're ready, you can have an electrician, run a dedicated outlet into your garage. Or you might find that, it's really not that inconvenient to have a cord running through your doorway, but, I could definitely see why people would not want to have that. So, it's kind of just a band-aid, but you also might have this dedicated into your garage for some other reason. Again, somebody might have had this and then like a outlet adapter to step that into something that's capable of charging up their RV or something like that. So our takeaway for a NEMA 1030 and a 1430 is it's a 30 amp outlet, and with our 80% rule, it gives us 24 amps that we can charge with. Our 24 amps times 240 volts equals 5,760 watts divided by 1,000 watts per kilowatt, and that gives us 5.76 kilowatts. The 5.76 kilowatts per hour gives us 57.6 kilowatts per night. So if you have like a Chevy Bolt or something like that, a Chevy Bolt has a 60 kilowatt hour pack. So this outlet would pretty much like be perfect for a car like that. It would give you more than enough range to kind of start each morning with a full charge. 57.6 kilowatt hours times 3, it gives us about 172.8 miles per night. Again, this is worst case winter, so multiply by 4 if you want kind of like a guesstimate of your summer range. Um, Also, 3 miles might be conservative if you have like a very long journey into your office. So highway miles generally are less efficient because you're not using regenerative braking. So you might get closer to like 3.3 miles per kilowatt hour. Um, but the nice thing with like those really long trips into the office is generally like your heat doesn't work as hard because your cabin eventually gets up to temperature and that kind of thing. This is 3-wire circuitry, so there's 2 hot wires and a neutral wire, but it's typically not used anymore because it lacks some of that safety from a ground wire. So typically, if you had an electrician come out to your house, in general, I don't think they would put one of these in, but it might be something that you have from an older home that you might be able to utilize. So they make chargers on eBay and Amazon and things like that that can plug into these easily. Or they sell adapters, so you could convert this into our next outlet plug. So we could change NEMA 1030 into a 1430 with an adapter. So NEMA 1430, that also gives us a capability of 172 miles per night. I left the math out of this one in the NEMA 650 example because it's kind of demonstrated on the previous slide. So this one's a 4-wire circuit. It has 2 hot wires, a ground, and a neutral wire. So this is just a couple examples of it. So you have, your prongs here. This is your ground, 2 hot wires, and then you have a neutral here. So the reason I have all of these outlets kind of demonstrated is you can kind of look into your garage and see what you have if you already have something like this and match it up and know that you can, hey, I have a NEMA 1450 in my garage. I can charge 288 miles per night, or I have a 1430 plug, so now I know that I can pretty comfortably get into work every day with 172 miles. There's some ways to get creative too. Um, so if you have in our mudroom example, we have a 1430. This is a 1430 here with the 2 prongs, kind of like the L-shaped here, and then I'm not sure what you'd call that, but essentially it's your 1430 plug. So in this example, somebody from the Minnesota EV Owners Group sent me a picture, as well as some of the other pictures that you saw in the presentation. So they have their dryer outlet split into their Tesla adapter as well as their dryer adapter. So the big safety note here is you can only use one item at a time, or it will basically like pop your circuit, because it will overload it, because you would have essentially, if both of these drew 30 amps at the same time, it'd be drawing 60 amps off of a 30 amp outlet. So naturally you could know that would throw the safety device in that circuit. So but again, we're stepping that down to 80%. So this Tesla adapter would be charging at about 24 amps. So as we saw here, that gives us about 172 miles per night. And it's important to use a splitter because outlets wear out from repeatedly switching cords back and forth between like the charger and a clothes dryer. Similarly, like even your standard wall outlet will wear out eventually. So it's generally a good idea to like just replace that going into an electric vehicle, because it's good to have basically like a fresh outlet to work with. So it has, if there's loose connections and things like that, that can cause heat from the poor connection. So just extra safety there. And then buying a EVSE. EVSE is also referred to as a charger. So EVSE is a electric vehicle supply equipment, and it's used to bring power from an outlet to the vehicle. So two primary types of end connectors is the J1772. So that's what we have outside of the Minnesota Pollution Control Agency at the charge point chargers. Um, and all EVs can use it, even Tesla, because Tesla has an adapter that converts this into the Tesla plug. So basically, you put a little, maybe like 4-inch adapter on, and it will allow basically like this to plug into an adapter that converts to this. So this is your Tesla plug. Some chargers just have this. So in that instance, you generally cannot charge other EVs with that unless you have one of the, like a special adapter from that. The EVSE rating, the EVSE amperage should the EVSE amp rating, the EVSE amperage should always be lower than the outlet you're using multiplied by 80%. So a 50 amp outlet can use a 40 amp or lower EVSE. So, and then for 30 amp outlets, they can use a 24 amp EVSE or lower. So NEMA 1450, you might have, like 3 or 4 different options for different amperages. So, and the reason that you might want that is you can, basically like buy different adapters and that kind of thing if you want to get really advanced. But just an example, they might have a 16 amp NEMA 1450, 24 amp NEMA 1450, as well as like a 32 amp NEMA 1450, and then finally a 40 amp NEMA 1450. So similarly, if you only have a 30 amp outlet, you won't want to exceed a 24 amp EVSE. And then a NEMA 1450 outlet can accept a NEMA 1450 EVSE rated for any amperages between 16 and 40 amps. So in general, there's nothing that you have to worry about with a NEMA 1450 outlet because everything will be under that maximum load rating of 40 amps. The nice thing with the Tesla mobile connector, if you happen to be interested in that type of vehicle, is there's basically this charger that you buy, and this is the Tesla plug, and then this is like your main EVSE component, but then you can change out all these adapters that plug into this end right here. So you could buy one for your regular wall outlet. You can buy one for your NEMA 1030 plug here. You could also buy one for your NEMA 1450. Oh, sorry, NEMA 1430, and then your 1450. So, but anywhere in between, I mean, there's some 20 amp outlets that you could install in your garage, and basically you'll just buy whatever you need. So if you have like a family cabin that happens to have like an old 240 volt circuit in there, and you're not sure if you could install anything larger, you could just go up to the cabin and make sure that you know what outlet you're looking at, and then just buy the appropriate adapter for your charger. And then supporting the circuit. So the circuit, you're going to have your breaker, your wiring, and then your outlet. So that's all going to be run from your electric service panel. So generally we don't want to exceed 80% of the panel's capacity, just like how we didn't want to exceed 80% of the circuit for the outlet. So if we have a 100 amp electric panel, we don't want to exceed 80 amps continuous load. And then a 200 amp panel, we don't want to exceed 160 amp continuous load. So typically, because when you're running all of your calculations with an electrician or something like that, they're going to take into account your like air conditioning, if you have an electric dryer, if you have an electric water heater and things like that. So they're going to use all those things and take those into account when they're saying if an outlet will be safe or not. So generally for a 100 amp service, you're going to have a 20 to 30 amp circuit maximum, because you're probably going to have an electric dryer as well as an air conditioner that are reasonably going to run at the same time. So anything higher than that would jeopardize that 80% rule, and jeopardize, going over the 80 amps that we can have running at the same time. And then also all the other things in your house, so all of your lights and televisions and things like that. So that just there's layer upon layer of safety in electrical. So and then for a 200 amp service or 150 amp service, generally those would be capable of having a 50 amp charger on those. However, sometimes when you have like a 150 or 200 amp panel, you also start having to take into account that you might have an electric range or electric oven that's running off of those. So that might push you over your 150 amps that you'd be able to run. So your 150 amp example, that would give you about 120 amps that you could have running at once. For 200 amps, again, you could run 160 amps continuously. For your electric panel, this is just like a kind of a cutaway I found online that kind of gives a good example of like just what you might be looking at with an electrician. So this is generally your main breaker. So you're going to have a rating on here. I think that this example, it's a 100 amp panel. So in this example, this could run 80 amps at once. And then these are your different breakers that you have. So anything that has the two breakers on the same thing, that will basically like tell you that that's a 240 amp panel. 240 amp circuit. And that covers basically everything. I think I have enough time to basically like run through an example of finding EVSE on like Amazon. So I'm going to go ahead and do that really quick. So I found just a quick search. I just typed in NEMA 1450 and charger, and I found these different examples. So again, here's what we're talking about. So your 1450, although it's capable of 40 amps, this is kind of like your limiting factor here. This is your 32 amps. So you would use 32 amps in your electrical calculations that I provided earlier. Another example is 240 volts, 16 amps. So this would be our limiting factor here, but you would still have your NEMA 1450 plug. So, but the nice thing here is you can obviously tell your 16 amp charger is considerably less than your 32 amp charger. So if you only need a 16 amp charger, but you want to run like a NEMA 1450 just for future proofing, you could kind of get a charger like this to start off with, and then you could work your way up to something like your expensive charger with your 40 amps. So you can adjust this internally from 16 to 50 amps. So essentially you could have it as a plug or hardwired. But it's nice to kind of like start with something lower because you might have a big initial investment if you're getting an electric vehicle for the first time. Otherwise, I think that covers everything. So thank you for your time and hope you have a great day.